Welcome to another episode of
HurricaneBusters!
Our story begins in a small port city on the Atlantic coast, or at least what used to be a city. A hurricane dubbed the Cyclone swept through its streets, destroying homes, trees, and wildlife. Typhoon Tiffany walks among the carnage and laments the loss of life and habitats due to such a tragic event.
Oh my, what happened here? The whole place is destroyed. What could cause such a disruption? This was the work of the Cyclone. He destroyed the beautiful coral reefs and sea creatures. The Cyclone caused huge waves and turbid waters to shift massive amounts of sand, which resulted in killing the sea sponges, the sea whips, and broke apart the coral reefs. Poor seahorses. They are territorial organisms, which means that they cannot flee to a safe place, because they are often wiped out by the rough undercurrents and swift changes in the water temperature and salinity formed by a hurricane like the Cyclone. There are many cyclones like this before. Like Hurricane Joaquin, this major storm destroyed many areas in the Bahamas. I still do not know why things this terrible happened.
Typhoon Tiffany stood at the water's edge, turning to notice her two friends, Cyclone Cindy and Hurricane Howard, coming from the HurricaneBusters headquarters.
Hey guys, over here!
What happened here?
The Cyclone decided that it would be fun to come and destroy this part of the city. He destroyed the coral reefs, so now it may take up to years or even decades just for them to recover from damage.
Let's go to the temporal typhoon machine to take us back to before this whirlwind of a mess.
The tropical storm trio entered the laboratory at HurricaneBusters HQ, leapt into the temporal typhoon machine, and traveled back in time just before the cyclone began. Once there, Cindy began to discuss the chemistry behind the formation of the
A
cyclone.
low-pressure system, where the pressure is lower at its center than the areas around it, is formed over the warm ocean water, which causes the warm air to rise. With greater warm air rising, the more water vapor condenses.
Wait, what does condensing mean?
Good question. Condensing is when the water vapor changes a physical state into liquid droplets. It is an exothermic reaction because heat is being released. Next, when the warm air combines with the winds blowing across the ocean, the warm air is pushed together and the air masses collide, causing the air in the center to rise. The air masses need to collide with the right orientation and enough force to form an updraft. Also, the air masses consist of warm air, since it is what increases the speed and the force of the collision, causing the ginormous whirl of a hurricane.
Wait, doesn't that relate to the particle theory?
It sure does. Great connection, Hurricane Howard.
Thank you, Cyclone Cindy. I think I figured out how the cyclone was able to use those pressure systems to become so powerful and sustain himself.
How so?
If a cloud is south of a low-pressure system, it will naturally move north towards it, but its greater eastward speed will cause its course to curve to the east. If a cloud is north of the same low-pressure system, it will naturally move south towards it, but its greater westward speed will cause its course to curve to the west. If many clouds converge on the same pressure system from all directions, a hurricane is formed. If they converge on a high-pressure system, a far less common phenomenon called an anticyclone occurs.
But what makes the clouds curve? Why don't they just move straight towards the pressure system?
Oh, I'm glad you asked.
The reason for this is a consequence of motion on an object that rotates like the Earth. This phenomenon is called the Coriolis force, named after Gaspard Gustave de Coriolis, who presented this concept to the Académie des Sciences in Paris in 1831.
So, how exactly does the Coriolis force work?
To understand the Coriolis force, I first have to talk about Coriolis acceleration, which is the idea that when an object is rotating about a point while also moving relative to that point, the object will receive an acceleration perpendicular to its radial velocity. This idea is modeled on this velocity time graph. In terms of hurricanes, a cloud traveling north experiences an acceleration east, while a cloud traveling south experiences an acceleration west. Since a cloud in the northern hemisphere will have more velocity traveling south towards the equator, the hurricane it forms will be counterclockwise, overtaking the less powerful air masses moving northeast. This concept is the opposite in the southern hemisphere, which has clockwise hurricanes. Hey, here's a fun fact for you two. The only difference between a hurricane, a typhoon, and a cyclone is the location on Earth where it takes place. The word hurricane is used in the Atlantic and Northeast Pacific. Typhoon is used in the Northwest Pacific, and it is called a cyclone in the South Pacific and Indian Ocean.
Okay, well now that we know all this information, what do you think we should do?
We can travel back in time and warn everyone about the coming storm and how they can protect themselves.
Yeah, that sounds good. Let's
go! A one, a two, a 1, 2, 3, 4. Hurricane, you are giving me so much pain. Better bring out my weather vane to see when you're coming around. Oh, hurricane, I don't know what I want to say. I hope that you're not here to stay, or else I'll run underground. I don't want your windy blows knocking me to and fro. I wonder if you know that I know of your forces, Corio. Oh, hurricane, please let me just walk away. Please don't bother me today. Just leave me alone. Oh, hurricane, I don't mind watching the trees sway, but not like when they're this way. I just wanna go home. I ain't no typhoon tycoon, but I know that you're a-coming soon. And I'd rather be caught in your eye, gazing up at the moon. Hurricane, I swear you're driving me insane. Please never come back again. Listen to this tune. Oh, hurricane, please listen to this last refrain. I ain't never gonna say it again. Now this song